Hello, everyone. Welcome. Thank you for joining our DevTalk webinar. This is our second session on the Zebra's mobile computing suite. Today, we'll give you a brief overview of the suite and take a closer look at the product recognition, text OCR, and entity viewfinder. A quick note before we begin, this session will be recorded. And all DevTalk webinars are made available on YouTube 3 to 5 days after the live event. Everyone is muted today, and if you have questions, please submit them through the Q&A box in the Zoom, and we'll address as many as we can at the end of the webinar. And for translated captions, our new feature, select your preferred language at the panel below as well. With that, I'll hand it over to our first presenter, Nicola Desault. Thank you.
Thank you, Pam. Thank you, Pam. I hope you can hear me well. And good day, everyone. As said, I'm Nicola. I'm a software engineer on the mobile computing team of Zebra. And as an agenda today, we start with a recap led by me. Then Kranti will present some advanced topics on the product and sharp recognition. Then it's the turn of Lowkick on the OCR, and before that, I'll introduce some advanced OCR settings that we didn't cover last time. Last time we introduced the AI suite as an integrated portfolio of AI enablers, AI blueprints, and solutions. So like AI companion. Specifically, last time and also this time, the scope of the conversation would be about the AI enablers, where we identify some specific models that we developed for our SDK. Last time, during the October DevTalk, we specifically introduced the barcode localizer and the text OCR recognizer. Today's focus is most on the product and sharp recognizers. You can see the picture on the right side of this image. And for those who were not in the DevTalk last month, the QR code on the upper side of this slide lands you on the recording of that DevTalk. With that said, I'd like to kickstart a quick recap of what we covered last time. And the first thing is why choosing the Zebra SDK of the AI suite. First of all, remember that this AI suite product was created by Zebra for Zebra, and so highly optimized for our devices. We know the products, the chipset used to build them. We know the software stack loaded on them. So I said it's optimized for our devices. Not only built because we know, of course, how our devices are inside, but really continually improved against our available SDKs and fine-tuned. This is something that is not happening for general purpose SDK, OCR model, barcode recognizer that you could find out there. It's also future-proof because the SDK is not targeting a specific device, but a platform, a chipset based on a specific chipset. And so once you have created an application for one device, you can extend it with minimal effort to any other device based on the same platform. And this is reducing a lot the risk for developers. AI Suite is a professional product that we support specifically with updates, and we manage its evolution and its roadmap with implemented, for instance, and understanding our customer specific needs. And so on a monthly basis, you get new features, new updates, fixes if necessary, and so on. It also comes with a lot of resources, use case oriented applications, so blueprints, and we'll see some at the end of this presentation. So let me then move to recap how the enablers of AI Suite are developed. So the models are the most important object there, is where the magic happens, and so they are the main goal of this SDK. But you also need to interface this model and work with them, and so that's why we developed a developer-friendly SDK called the AI Data Capture SDK. We also made available a number of resources. The first of these resources is the developer portal, your first stop, where you can find any reference to the AI Suite, and from there you can access all the documentation based on our portal Tech Docs. You can reach GitHub to get samples made available specifically for this SDK, and also have access to our public repositories where the models and the SDK libraries can be downloaded and integrated into your project. A little down with the details of last time presentation, just for everyone to be on the same page. Some object names that we introduced last time. So everything starts grabbing a frame, an image frame from a camera. Camera X from Android is the preferred framework to do that. It's not the only way to grab a frame from the camera, but Camera X allows developers to leverage the analyzers, and that's why we created and made available through the SDK the Entity Tracker Analyzer. It works as an engine that picks, that receives the image frames from the camera and pass them to the decoders and make the results available through entities to developers. It works exactly as MLKit Analyzer does from an input-output perspective. That's why it's interoperable with that analyzer. And if you're already using the MLKit Analyzer in your application for general devices, when your application runs on a Zebra device, you can easily replace the MLKit Analyzer with our Entity Tracker Analyzer to benefit from all the features offered by the AI Data Capture SDK. Last time we presented in more depth the barcode decoder and the text OCR, and we today I'll also cover more on the text OCR, as I said. We also introduced the Entity Viewfinder quickly, just showing how it appears. But today, Lowkick from our team will share more on that. And finally, last time we saw some screenshot of the demo application available to developers and the quick samples too. With that said, I leave the stage to Kranti for the product recognition. Kranti, if you want to jump in.
Yeah, thank you very much, Nicola, for the introduction and the recap. Yeah, hi everyone. This is Kranti Kumar. I lead the AI Suite SDK from Zebra. So in the previous session, we spoke about barcode detector, barcode decoder, how it works with the detector, and the text OCR as well. Now we're going to talk about product recognition and what are the steps involved in the product recognition process. So the product recognition basically, identifies the products present in the shelf and recognize them with a similarity score saying that this is a new product. So if you look at the steps involved in product recognition are, initially it starts with localization of the shelf that includes, localizing shelf itself along with the labels. When I say labels, the price labels and the product split. So the next step is once you have these localized products, feed these localized products into a feature extractor capability of this SDK, which extract the features of the product, each individual product. So as you see on the left side localizer, each product is separate, a localized item. So pass these products to feature extractor one by one, and it extracts the descriptors. When I say these descriptors, these are nothing but mathematical representation of the feature, how it looks like. So basically, it is a vector of floats in terms of how this product's structure is, right? Then, the extracted features are then, stored by using feature storage capability, which enables, to generate a set of features in it that provides index generation mechanism. So once this index is generated, the index file along with the localized crops with the descriptors are then fed to recognition block of the SDK. That's the final step in this process of product recognition, where, yeah, as you see, the last step here is recognizer, and it identifies these products based on the index file that is fed, and it runs the similarity search and the recognized product label information along with the similarity score is being written. So this is a whole pipeline where you see these 4 steps are involved. We will see each individual item in the coming. So the next, we'll see a quick, demonstration of this product recognition, how it works. So Nicola, please, yeah, play the video there. This is the demo application. Thanks, Nicola. Yeah, on the left side, what you see. So it selects the DSP and you set the input size, the model input size, and you see the first step is you recognize, localize these products, and this is the process of enrollment where each localized product is then added with its label. So in this case, it's a numerical representation there, and you see these are getting recognized. And when you see a similar product, it's also recognized in the other shelf here. Thanks. Yeah. So the first step, as I said, the typical product detection. The products includes the boxes, scans, etc. And also it has shelves, pegboards, and labels that are detected. So before passing it on to the descriptor, yeah, this is meant for the product recognition. So you filter the detected products and pass it on to the extractor and create a database that enables the enrollment of these products. And then pass them further to the recognition along with the index file. Let's see what's the localizer looks like. The product localizer. Yeah. Nicola, if we go to the if we can go to the next slide. Yeah, thanks. So yeah, in the product and shelf localization, as you see on the left side, each shelf containing these products and the corresponding labels are localized, and the model for this localizer is product underscore shelf underscore localizer. Probably that we will see in next coming slide. And the detections are then passed to the feature extractor block in the next one. this feature extractor, extract using the product features. Yeah, Nicole, if we can move to the next one. Thanks. Yeah. The features are then, extracted out of each localized product, and the features are, represented as descriptors. So this is again a vector of float numbers, which then saved using the feature storage block within the SDK and the database file. While either you could do this enrollment as a next step, but whenever you get a new product, you could add these descriptors to the existing database as well, right? So the next step in this is to generate the index file. That process is called enrollment. That is using feature storage block, right? Next one, please, Nicola. Yeah, thanks. So as I said, feature extractor enables these capture of the descriptors and then save to the DB. So currently, this enrollment happens on the device. So there's a plan to do this on the cloud, probably maybe in one of the upcoming sessions that could be discussed. So the current on-device SDK provides this facility already to enroll these products on the device itself within the SDK. Right? So the next step involved is how this index gets generated, right? So once you have this database file, you pass this on to the recognition block. So in the feature, yeah, this is what I meant, right? As you see, the whole pipeline, first step to the localization and then to the extraction. Each of these extracted features are stored in the feature storage. And once you pass the DB file path to the recognizer, again, this DB is internally managed within the SDK on device. A recognizer enables the index generation process. Once you have the product index, right, it involves now the next step to actually recognizing the products, as we have seen earlier in the demo, right? So once the index file is fed to the recognizer block, the process of localization and then feature extraction followed by index plus the fed descriptors are used further to the recognition. So recognition outputs you whatever it matches the similarity score. So there is a threshold that you could configure via API for the similarity threshold. And for each of these products that are recognized, the similarity score along with the product information or the label that is written as a result of a recognition block, right? So this is the whole pipeline or the process how you could enable the product recognition use cases. So the use cases could evolve, such as say if you want to detect a misplaced product or detect gaps in the shelf within the products if there is a gap. And also if you want to do a compliance checks, for example, price compliance check. So the label is also written and associating that with the product, and then based on the SKU, the application developer could search in the database to get the price. What is there on the database plus what is visible on the label, is it correct or not? As a compliance check that could be added. For more, there will be advanced use cases. For example, the compliance checks like planogram compliance. How can this be done? So this building block enables all those advanced use cases, to build on top of this product recognition pipeline. Now we will see how this programmatically all these steps are explained here. Yeah, Nicola, please play the video.
Should start now.
Thanks. So in the previous slide, discussion of how you include these models and the SDK, it is similar. So you specify the model to be used here. So in product and shelf recognizer is the model name, and the right version is available in the tech docs. Then you specify the SDK artifact details. AI-data capture SDK is the artifact, and mention the version numbers. Once you have all these details added in the TOML file, so this is basically how general Android development happens. These are available in Maven, so you specify these and you get the artifacts downloaded automatically while compiling the application. Please refer to the latest tech docs for the right Maven URL, and that will that also has the steps to integrate these models with the right versions. Once you have these initial dependencies added, add all the necessary packages that includes within SDK and localizer, feature extractor, storage, and other things. So the very first step involves initializing the SDK and initializing all these blocks: localizer, feature extractor, and recognizer. Please note that the model name is same for the self recognition or the product recognition and the feature extraction. While initializing these blocks, the model name has to be passed. We will see how this happens further. And as I said, very first step is to initialize the SDK using the init API. And once the initialization of the SDK happened, the required blocks have to be initialized. For example, the localizer and feature extractor. Please note that all these exceptions are documented, and application needs to handle them as and when the API is used. Yeah, once the initialization happens, let's look at how the other blocks like localizer and all in. So create these localizer settings first. As you see, the localizer settings involve specifying the Maven model name, and similarly initialize the feature extractor. Once these two blocks are settings objects are created, specify these options includes inferencer options. So there are auto option is also available. You could choose a DSP for the better performance. Specify the other parameters like product index and product label file, that is nothing but product txt, and then initialize the recognizer block with the index file that is generated. So this is the first step where you initialize the localizer block with the created settings. This get localizer API asynchronously returns the localizer instance, and it uses the completable feature from Java where you get all these callbacks in a background thread that is managed by the executor here, what is passed on. The initialization is similar for feature extractor and recognizer as well. And once all of them are created, you enable the product.index and product.txt file from assets and pass it on to this. So copy from assets and for the index file as well as the label file is mentioned here. And as I said, all these APIs through to the respective exceptions as the API specifies, we need to the developer needs to handle the exceptions. Once this initialization of all these blocks or the steps in this pipeline are done, let's see how the recognition or the starts, including the starting from the first step, that is localization. As you get this localizer object, the first step, you get the imager, the camera image from the camera X API, or you could use camera to one. But we suggest to use the camera X analyzer API, where you get the image proxy object and convert it to bitmap and pass it to the localizer block. The localizer block then gives you the bounding boxes of each of these products and shelves. Pass these localized product information to the feature extractor, and the generated descriptors are then taken to recognition block. The recognition block then provides you the found recognitions based on the match that internally the SDK has done based on the model. So these recognitions again involves the recognition API returns the found the matched product recognition product objects. We will see further, how these can be rendered on the viewfinder tool. So as you see, the then accept callback will give you the final output of the recognitions, and developers can, draw them on the UI. Once all these, the recognition process is done, the respective resources have to be released using the Dispose API. So this is how, as a pipeline, we enable the product recognition that involves all the steps that I mentioned. So SDK, the documentation for all these steps is available in tech docs, and as we see, the enrollment process is done through feature storage, and the next step for that was to use the cloud service, which can be covered later once it is available. So I think this is all about product recognition, and with this, I will hand it over to Nicola for TextOC.
Yeah, thank you, Kranti. Thank you so much. So I said I'll cover some advanced configuration topics about the text OCR that we didn't see last time. I thought to also cover the basic setup of a solution using the text OCR. This is something very similar to what Kranti has just shown for the product recognition. So I'll move through this quickly. You need to include the recognizer. In the model name is text-OCR-recognizer. In your bitgradle file, you also have to include the AI data capture SDK with the proper version number. Then in the onCreate, so you can do anywhere in the main thread, you have to initialize the SDK and initialize the text OCR object. To initialize the SDK is pretty straightforward. You just have to call the get instance and the init method, while to initialize the text OCR is where the settings come into play. You start creating a text.OCR.settings object, invoking the model name, and you use this object to add the restrictions of your settings. As you can see here, the first thing that you want to define is the inference processor. We'll see later the option available. In this case, the DSP was chosen, and then you also set the model dimensions. We have a slide for that to explain its meaning, but just to understand the flow, then you pass the text OCR setting object to a static function that can get text OCR to have the real OCR instance available to you and use it when needed. At some point in your business logic, you want to perform an OCR operations. In that case, you invoke the process image method on that object. If this is done through the camera X, you're receiving an image proxy, but our text OCR process method processes the image data format, and so you need to convert the image in that case. And the results are returned as a list of paragraph entity in the case of the text OCR, which means that you subsequently can parse in a loop the nested structure made of paragraphs, lines inside a paragraph, and words inside a line, and finally decide what to do with the final word. The decoded value in this example is the word identified by the OCR. I mentioned the model input size in these basic settings. The model input size is about and defines the resolution used by the AI model to process the images. You typically have the option between a 640 by 640. Usually, it's always a square image, a square dimension that you specify. It's good, it's fast, but it's good if the text is large or you're very close to the text, so it appears with a certain, is well readable inside the image past. You want instead to use a larger dimension like 1600 by 1600 for a better accuracy. If the font you want to read is distant or very small, but of course you expect a slower performance. You can also specify a custom input size, for instance, 800 by 800. It must be a multiple of 32. That's the only restriction, and could be a good balance between speed and accuracy. Camera resolution also affects the way the text is decoded and recognized inside the images. Same reasoning, you can use a lower resolution for large text and you gain speed. In that case, otherwise you have to scale up with resolution depending on the specific use case. That's something that you typically control through Camera X or Camera 2 libraries in Android. The processor options are the DSP. So you ask the SDK to run the inference on our internal digital signal processing, which is available on some devices. Otherwise, other options are the GPU, the graphical processing unit, or the CPU, which is, of course, a kind of fallback situation when the other processor are not available. So the text OCR settings used to fine-tune the engine for your specific use case are divided into three main sections, and the text detection is the first. Here you want to better specify how the text is identified across the image, and there are three levels that you want to understand and use in your application design. First of all, it's a work at pixel level with a heat map, deciding which pixel to keep and which to drop, depending on the probability they belong to a letter or a glyph or not. Then you have a filter on an entire area identified as including the text, and then secondary geometry filtering aimed to decluttering the image of dust, small points, lines, and so on. The pixel heat map, the heat map threshold, is your main dial. You want to start playing with this parameter first in order to raise it if you want a sharper detection for highly contrasted labels. You want to lower it if you want to also apply the recognition to lower contrasted text or partially blurred that would otherwise be discarded if the threshold would be higher. The other parameter is a box threshold, and as I said, this is about when you increase it, it filters out partial boxes, so logos, for instance, or fragments. While if you decrease it, it recovers everything is in the image and applies the processing. About the fine-grained noise suppression, you have the min box area for tiny spots on the image, and the min box size for skinny object like the dividers, the lines, or something similar that you want to drop for the recognition. You also have available min ratio for rotation, which applies automatically a rotation if it detects text that is displayed vertically in the image, and the box expansion and unclip function that adds margin. Otherwise, the identified clip is really around the letters that are going to be identified. So if you want to ease the recognition, adding a box expansion could help the recognizer. Another set of parameters you can play with is about the text recognition. So these parameters are affecting the way that characters are assembled into words. And so you want to take into consideration the decoding top K ignore cutoff, which is a parameter that, if increased, allows to have more options to choose between ambiguous alternatives, for instance, a 0 and a no, a B and an 8. If you want to keep these alternatives and maybe filter them out at a later stage with a different algorithm by for instance, regex, you can increase this parameter. Instead, if you want the algorithm and the model to choose for you which is the best fit, you need to lower this value. The decoding total probability threshold is about adding a character only if you're very confident of it. You specify a number above 0.9. If you want to keep also more uncertain choices, you can lower it. There's a cue to understand if this parameter is set to the right value, and it's about understanding and looking the output and see how many question marks placeholders are in the return values. If there are many, it means that the threshold is too high and you need to lower it a bit. It's, of course, a work of adjusting these parameters through iterations, and so you need to start playing with them one by one, adapting your application to the specific use case. On the other side, this is the richness of our offering with the models that perform the OCR on text. Another parameter is this one, the coding max word combinations, that limits the number of words returned. So if you increment this, you get more words. Otherwise, you need to keep it down if you want to have just one choice. There are also a couple of other parameters. The flip one, if enabled, this is a Boolean value. If you enable it, it runs the recognition twice. So on the original image and the image rotated by 180 degrees, it takes, of course, twice as much in time. So be aware that it needs to be enabled when really necessary. The tiling instead must be enabled if you're targeting strings longer than 15 characters. This might happen with serials, tracking numbers, part numbers, everything we find in our in the enterprise workflows. In that case, additional parameters are available for the tiling. For a complete reference, frame the QR code on the right, and you land on the DevTalk page where everything explained in details. The final bucket is about text grouping. So the way the words are assembled into lines and lines into paragraph. This is this aim to respect original semantic order of what in the has been framed in the image, and so we have three parameters affecting the way that words are assembled into lines with the distance ratio. I've added a picture displaying how this works. If you keep it at the default value, two words appear in two different lines. Instead, if you adjust it by increasing it, the two words are combined in a single one. This might be useful, for instance, in fields like addresses on a label, where the address name and the city might be very distant, but on the same line. If you want them to be compacted, this parameter can help to achieve that. The second parameter is about the height distance ratio, and it's about combining words with different fonts. So you can see in the sketch here, the word number one has a small font, the word number two is bigger, and they would be kept separate by default. If you want them to be combined, you need to increase this value. And for the center ratio, the third parameter, this is about combining two words on different line, visually different lines, and when you want them to be returned in the same line instead. About combining lines into paragraphs, there are two parameters available. The first is a paragraph height distance. You can see in the picture how it works. So if you increase it, you tend to add and include them in the same paragraph. Otherwise, it's on separate paragraphs. And similarly for the height ratio threshold, if you lower the value, the joining lines with different heights are combined. Otherwise, it prevents that to happen. Again, in the QR code, the specific explanation for each parameter is found there. I also wanted to introduce and present a couple of use cases to show how these parameters can be combined all together to satisfy the specific use case. The first one is about the delivery parsers verification. So it's a kind of single shot accuracy that you look for. So a delivery driver has to frame a tracking number, and optionally to read the house number and the street name. And the challenges of such a use case is the type of light, glare, angles of different types, label conditions that can be faded, and so on. What are the real parameters that you need to tweak? For the text detection, for instance, the heat map should be decreased in order to better identify text if the label is faded out. The enclip ratio should be slightly increased because scanning at an angle sometimes make the text less recognizable. And the box threshold slightly decreased because you want to have a first time read success. So you don't want to, you can tolerate false positive, but you want to have a result at the first scan. And about the text recognition, probably it's good to enable the flip feature, because sometimes parsers are rotated in a way that you want to frame and get the result anyway. Slight increase in the decode top ignore cutoff, because the poor light can easily lead to misunderstanding of symbols like the B and the 8 and the S and the 5 and so on. And also you want to enable the tiling, because tracking number, as I said before, can be longer than 15 characters. And about the grouping, you want to increase all the parameters available, because, for instance, address line have often large gaps. You want the recognition to be tolerant to variable heights in the font, and also compensate for the distortion that's a third parameter. I'm also presenting a second use case, for instance, in the healthcare space, where we figure out that a nurse needs to quickly find a drug, panning the device across the boxes. Here we want the application to be absolutely performant. The challenge is to read text in high density and feel full of clutter, and also the light can be a challenge. For a use case like this, you want again to read everything available, so you decrease the heat map threshold. Instead, the bulk threshold should be high in order to declutter everything's not needed for decoding. And the spatial parameters, the mean box and mean ratio, are slightly increased or kept default, because, for instance, you want the small letters like MG or ML that are often found in medication boxes are filtered out because are irrelevant for the search. For the text recognition parameters, decoding the word combination max word decoding, you want to increase it because we need a single. You want to decrease it because you want a single word to be returned, not an option to choose among them. And then you also want to set high the probability, the total probability, because you want only one result that is considered extremely confident. You're not going to enable tiling because medication names are usually not that long, and you don't also need to tweak text grouping parameters because you're searching for a small word in the end and not phrases or multiple lines. I hope that these two use cases give an idea of what you can really do and adapt your application and the settings of each model to the specific use case to fine-tuning it at the maximum level. With that, I'll leave the stage to Laukik with the Entity Viewfinder. Please, Laukik.
Thanks, Nicola. This is Laukik Desai. Basically, I work for Zebra Tech as software tech lead. I am part of AI suite development. I typically look after Entity Viewfinder. So today we will see how to get Entity Viewfinder integrated alongside CameraX along with the Entity Tracker Analyzer. Just a quick recap what was discussed earlier regarding Entity Viewfinder. So what is Entity Viewfinder? So it is an entity agnostic or entity aware viewfinder, which is designed to seamlessly work with the CameraX application. It enhances the camera preview experience by visually rendering and interacting with the detected entities in real time. So from implementation perspective, Entity Viewfinder is built on top of a preview use case of CameraX. It is an extended or enhanced version of a preview view. For those who are aware about the CameraX would know about the preview view, which is a standard view or a standard viewfinder provided by CameraX, which has a capability to render the camera feed or camera preview. So the Entity Viewfinder goes a few steps ahead. It allows user to render entities as a AR, AR experience. User can easily style them with the ready-made styles available along with the Entity Viewfinder offering. Apart from that, we have integrated the camera controls in the viewfinder. The viewfinder is also adjustable, meaning to say we can resize the viewfinder, we can move it along within the screen boundaries. Also, we can toggle it back to the original dimension and snap it back to the original place. So on the right side, on the bottom end, we have a typical look of a viewfinder where it is hosting the camera controls, and it is showing the style pens or the entities getting rendered on the viewfinder as icon style pens. One more note, yeah. So the way Entity Viewfinder is designed, it is not tightly coupled with the rest of the components from AI SDK. In case if you have your own version of a viewfinder, you can still continue with it. But we would encourage to have Entity Viewfinder to be integrated in your implementation for the earlier mentioned benefits. Moving on to the next slide.
Yes, coming.
Yeah. Thanks, Nicola. So Entity Viewfinder mainly has these three components. One is Entity View, another is Entity View Controller, and the third one is Style Pane. Entity View is basically a visual interface that allows customization of viewfinder appearance and behavior. By using this interface, user can get it integrated into his UI layout and make it place it alongside his rest of the UI elements. The Entity View Controller is a high-level controller for all the viewfinder operations. It is the main interface where user would be registering the listeners such as entity, resize listener and then click listener. By using this interface, user would stage the entities to be rendered on the viewfinder and stylize them. The next is the style pane interface. Using this interface, basically, it is a visual representation of entities on the viewfinder. Using this interface, basically, user can style the entities before posting it on the viewfinder. Next, please, Nicola. Yeah, this is a high-level overview how Entity Viewfinder can be integrated into the CameraX alongside Entity Tracker Analyzer. Basically, it consists of three parts or three phases. First is the init phase, where we start with the initialization of CameraX and related dependencies and prerequisites. Post that, we initialize Entity Tracker Analyzer with typical configurations of barcode decoder. Followed by that, we have an initialization of Entity Viewfinder, meaning we set up an entity view and then we set up an entity view controller. Followed by the registration of listeners. Here we have entity view resize listener and entity click listener. As I discussed earlier, Entity Viewfinder is built on top of a preview use case of a CameraX, whereas Entity Tracker Analyzer is built on top of an image analysis use case of a CameraX. Both these two are independent of each other. They are running on both the on a separate ends of CameraX. So in order to establish synchronization between these two, the entity view resize listener plays a crucial role. Basically, which gets you the information such as a transformation matrix and the information related to field of view synchronization posted to the application, which needs to be registered to the analysis end to establish the synchronization between analysis world and the preview world. Next, we have entity click listener, by means of which a user can listen to the clicks happening on the entities. Next is as a standard procedure, we bind these use cases to the CameraX to the life cycle of activity. Third is a runtime phase where CameraX would start executing these use cases. The entity tracker analyzer would start receiving the frames, and in turn it would start producing the entities. This is where your business logic would come into action. You could retrieve the results from entities and then take action as your business need. From entity viewfinder perspective, this is where we would associate a style pane to the produced entities. The entities would be posted in a batch. So here we can associate style pane in a batch. stage it to viewfinder, and in one shot we can post it or issue a render call to the entity viewfinder to optimally render it on the viewfinder end. Next slide, please. Yeah, let's see how we can get entity viewfinder integrated into the CameraX application alongside entity tracker analyzer. For the simplicity sake, or to establish a context, basically, first I'm starting with the preview view, which is a standard viewfinder from the CameraX. We'll get it integrated. We'll see what are the integration points of a preview view, and later we'll try to swap it with the entity viewfinder, counterpart elements. Nicola, if you can play the video.
Should play now.
Thank you. So on the XML, this is where the preview is integrated. Coming to the variable declaration, these are the parts: entity tracker, analyzer variable, decoder variable, and the preview view. On create, we are creating the instance of preview view, followed by initialization of SDK and barcode decoder with a typical configuration of barcode decoder. Then we are initializing the entity tracker analyzer. This where we are registering the handle entities function. This would be invoked on behalf of when the entities are produced. Coming to binding use case, basically we start with the camera related configuration, followed by initializing the preview use case. Then we are retrieving the surface provider from preview view and registering to the preview use case. Then making the image analysis use case and eventually registering it to the camera provider, to the CameraX. This is standard steps to get the viewfinder going along with the entity tracker analyzer. On the right side, we see the preview view in action, which is a plain viewfinder basically. Now, as I mentioned, let's switch it with the entity view, which is a counterpart to the preview view on the XML side. Now coming to activity, I will swap the variable preview view with the entity view and entity view controller. For an example, I have taken a style pen. I've created a style pen of a yellow color bounding box. On create, replacing the preview view instance with the entity view instance. The rest of the steps remains the same of initializing SDK and then barcode decoder and the initializing the camera. Coming to initializing entity view controller, this is where we are passing the instance of entity view and the lifecycle owner as this activity. Followed by that, we are registering the entity click listener to the entity view controller. Yeah, and we have the transformation matrix and crop region. Basically, this, as I mentioned earlier, these plays a role establishing a synchronization between the preview world and the analysis world. So this is the another listener, a resize listener, which will be invoked from the viewfinder as on when the viewfinder is established first time, and then when the viewfinder gets resized. With this call, basically we need to update this information back to the analysis so that it can produce entities with the bounding boxes which the viewfinder understands. Yeah, coming to the entity tracker analyzer, we are swapping the coordinate system with the system view reference coordinate system, which the viewfinder understands. Coming to the binding use case phase, we are just swapping the preview use case surface provider. Now we are retrieving it with the entity view controller. Yeah, rest of the steps remain the same. The same use case are registered with the CameraX. It is just that the returned session camera is registered on the entity view controller for the functioning of the camera elements, the camera controls that it hosts. This is another function called applies resize specs in the event where, let's say, entity tracker analyzer is not available or it is not ready to consume this the resize event related specification. We would have cached the transformation matrix and crop region specification. We would apply it to the analyzer end when we see the next possible opportunity. So that is the first call as part of handle entities that we are doing. And then rest of the part where the actual rendering of the entities happens. So first we are clearing the entities posted earlier. Next, for each entities produced by entity tracker analyzer, we are trying to associate the detection bounding box. And at the end, we give a single render call for all the entities. Let's see it in action. Yeah, as you can see on the video right side, it is showing the bounding boxes for the decoded barcode. Yeah, so this basically concludes how we can get the entity viewfinder integrated as a basic integration steps. Next, I have a the configuration related details. Nicola, if you can move on to the next slide. Yeah. So here
I'll play
we will
this.
try to. Yeah. So here let's customize the entity viewfinder look. We are reducing the height of the viewfinder by 50%. Then in the lower block, we see a few more configuration related to viewfinder, by means of which we can enable disable the visibility of buttons, and then we can even define the default state for draggable and flash and zoom attribute. These are custom attributes available alongside the viewfinder. We are seeing it on the right side, it in action. The viewfinder is launched with a 2x zoom, and also the we can do the zoom action. We can go full screen. We can go back to the original dimension. The flash in action. Yeah, going full screen. Yeah, we can drag the viewfinder alongside, and then snap it back to the original location. Yeah, so this way we can customize the appearance of entity viewfinder. Now let's go to the activity, and let's try to introduce few more styles by means of which we can style the entities getting posted to viewfinder. Here I've introduced alongside bounding box styles. I've introduced icon drop in styles, named them as a recall pane, taken pane, and then operate pane. As you can see, we have a ready-made available icons that you can pick and choose for your operations. For demonstration purpose, at the handle entity call, we'll try to associate them when the certain sets of barcodes are decoded. Yeah, for demonstration sake, I've listed these barcodes and classified them as a recall list of barcodes and taken a list of barcodes and to be operated list of barcodes. Yeah, coming to handle entities part, this is where once the entities are produced, when we get the barcode out of one of those list of barcodes, we are trying to associate respective style pen to it. And this is getting staged to viewfinder. And eventually, let's say if the barcode data is not there, we are associating the detection related style pen to it. And eventually we are rendering it at once. Yeah, now you can see on the right side, apart from earlier yellow bounding box, we get to see icons such as flag, red flag, and then tick mark, and then a blue plus kind of sign. So this how easily we can pick and choose the styling for entities to be rendered on the viewfinder. Next, let's interact with the entities by means of click listener. Yeah, this is the click listener. As and when this is invoked, let's try to show the toast message of which entity has been clicked. Let's see it in action. Yeah, here basically we will try to tap on the center, bounding box with a green bounding box. Yeah, as you can see, when user is tapping on it, it is showing the toast message detailing which entity has been clicked. So this is how basically we can configure the look and feel of a viewfinder and even the style the entities before rendering it on the entity viewfinder site. So yeah, this basically concludes how we can make use of entity viewfinder functionality, how we can configure them for a look and feel and sizing aspect, what are the different configurations, and what are how we can stylize the entities before posting it to viewfinder. We have more details available on the official website TechDoc documentation. You can refer for more details. For coming to the entity viewfinder code snippets, this also integrated alongside entity tracker analyzer as a part of quick start sample. This is also available on the Zebra GitHub repository. Yeah, this basically concludes how we can get entity viewfinder integrated into the CameraX alongside entity tracker analyzer. Thank you. Over to you, Nicola.
Thank you so much. Thank you so much, Laukik. I appreciate we're well over the top of the hour, so I'll move quickly to the final slides. Here we're showing an interesting set of blueprints application that we developed to showcase the capability in the real world of our SDK with any kind of use case that you can imagine. Just to see it in action, starting from the left, we have the barcode find application where you want to look for a specific barcode and you see the entity viewfinder by Lowkick in action. The second blueprint is about the barcode counter, so it's literally enumerating and counting everything it's finding by panning over a shelf. Then we move to the text OCR demo, where text is shown in detection. Also, you appreciate you can recognize handwritten strings. The fourth one is a top stock, so the idea of picking and refilling or taking action on the top stock on a shelf by a product number, to move to find items on a shelf, and finally the compliance check. Reach out to us to the usual channels if you want to know more on the specific blueprint application and how to translate this and integrate it into your workflows. I'll come to a conclusion showing these slides, which is the list of resources available, the dev portal and the demo videos, the tech docs, and the sources on GitHub to make our SDK work. And finally, a second slide on resources about the demo application that you can consume through the Zebra Showcase app. With that, thank you so much for your attention. If there are questions, I leave the microphone to Pam, back to Pam, if you have something to share with the audience. Thank you.
Hello, yes, thank you everyone. And I'm going to hand it off over to Rajiv. He will take it from here. Thank you.
Thanks, Pam, Nicola, Lowkick, and Kranti. And apologize for the audio and video glitches that we had in the earlier session. We are slightly over time, but I hope it was an interesting session for all of you. I hope I'm audible. I'll quickly go through some of the questions that we've received. The first one is on the product recognition. What happens if a product is put on the shelf back to front, which means the orientation is different? Let me try to attempt answering it, Kranti, and you can pitch in if needed. Basically, this is a visual model. Localization would work. Kranti explained about how products are localized and then you recognize them. Localization would identify that it's a product. Depending on how you have extracted during the enrollment, if you have the different sides of the product enrolled, it would detect it as the same SKU. So that's how people work on detecting the product, irrespective of how it is placed. I hope I answered the question, but it's about how good your enrollment is. The recognition model will work if your enrollment is good. There was another question on how we could, how do I get a kind of support for testing your AI API in a lab or development environment? I think Nicola shared the portal where you could go through the GitHub sources. They are ready to use source. You can just reuse and get your applications quickly built. There is a tech docs where there's a lot of documentation on the APIs. There are sample and demo applications which you could refer to. You could always reach out to us through our developer portal if you need any help or assistance in any specific use case or configuration that you require. What devices can they use AI SDK on? So basically, again, on the tech docs, specific devices are listed where it is qualified today. We don't restrict running it on any Zebra device. By the way, this is only on Zebra devices. Specifically in Zebra devices, look out for devices that has a DSP component in it. The performance is much better when you run these models on a DSP. Look at our portal for products that are based out of 6490 platform. If you go to the tech docs page of AI Suite, you will find listed all the products that are today qualified. Predominantly, the 6490 based platform based products are all qualified today for this. And as Nicola said, going forward, more and more products will get added to this, and you will be able to build once and deploy on all products. There's a question on where can we find the slides. I think the recording will be posted in YouTube within 3 weeks' time. That's what I think Pam initially highlighted. There is a question on Xamarin and Android. Right now, the APIs are meant for Java and Kotlin. More platform support will be rolled out pretty soon. So watch out for the space. There is another question again, I think, on Zebra devices, which I answered. But there's also a side question. Is there any further licensing needed to use these libraries? As of now, the SDK is free. All the models that we discussed today are all free. You can easily use it on any of our devices. Whatever we have been explaining so far, it's ready to use on any of your Zebra devices that are qualified. So look at the page for the devices that are qualified or compatible, and you don't need any license to run on it. There's a question on interesting question on the SDK models performance with MLKit models. The MLKit model, let's say for OCR, I think we answered it last time also. As you would have seen how Nicola explained, the kind of configurability you have, you do not get that from MLKit, number one. And we have been doing consistent benchmarking with multiple different SDK options. And our models perform much better on the use cases that our enterprise customers require. For example, let's say handwritten text. We have use cases where people come to us and say that I have a package where I have handwritten text on it, or a postage label where there's a handwritten text, and how do I read it? I'm not able to read it through any standard offering. Our models are capable of doing that. So the benefit or compared to MLKit is the data sets that we support is much more and very focused on some of the use cases that really matters. MLKit is a good model with respect to general purpose text where it is printed in known fonts. We have an advantage when it comes to specific fonts and types of data that you find. One last question I'll take. Is there a programmable way to share or implement database in my software that is a result of training on one device on product recognition? Yes, you could do that. Basically, the training or the on-device enrollment is not device specific. You use one device today. The on-device enrollment that Kranti talked about does an enrollment. You generate the index file, which you could deploy on thousands of devices, and all those devices during the recognition phase will use that index file to make the recognitions done. So yes, you could do your on-device enrollment using one device which you have, create the index file and deploy it, and you could leverage the product recognition across. There's also one more question that just came in, whether these models need training for better performance. We will be giving you options, again, a cloud-based approach to enhance your model performance. As of now, we have catered to most of our customer data sets we have from different verticals, but any scope of improvement, do reach out to us. Unlike the general purpose models, I think this is somewhere Zebra plays where we have that support system to cater to your use cases and give you a model that gets better out of your use cases. I think I've covered most of the questions. If I've missed anything, please do reach out to us through their portal. We will be more than happy to reply to your questions. And if there is more engagement required, we can even get on a call to discuss further. We'll be happy to help.
Okay, we want to thank everyone for joining us today, and apologies for running late and all of the technical issues with the sound and some of the video. And we appreciate you joining, and we hope that you have a great rest of your day. Thank you.
Thank you, everyone.